Hello students, welcome to CMIS online classes, and this video is for class 9 chapter number 10 and gravitation. Okay, so in our previous video we talked about gravitation and universal law of gravitation, acceleration due to gravity. Okay, so in this session we will talk more about gravitation. So let's start with mass and weight, as we discussed these two topics in our previous video also, but let's have a revision, that means continuation. So we talked that mass is constant. Okay, it doesn't change from place to place, and its SI unit is kg, kilogram. Then we talked about weight. Okay, so weight is actually the force of attraction by a earth or other celestial bodies. Okay, so it keeps on changing. Okay, because gravity of earth and moon, whereas that of sun and other planets is different. Okay, so if acceleration due to gravity is constant, that means at the same place, it means mass and weight will be same. It is directly proportional. Okay, as for example, if certain object weight is 5 kg, okay, the mass is 5 kg on earth, okay, in one place, you can say in Delhi, okay, it is 5. In London also the weight of the body will be 5 Newton only. But if it is in other planets, or we can say moon, it will differ. Okay, because the acceleration due to gravity in the moon is less than that of the earth. Okay, so let's talk about the same. Okay, just see here. Mass and weight is similar if the acceleration due to gravity is same. Okay, so here if my weight on the earth is around 56 Newton, okay, and on moon it is 90, but my mass is always 56 kg, that means it is same in moon also and in earth also, it will be same. Okay, only weight will differ. Okay, here we have a 5560 Newton, and here in the moon we have 90 Newton, but mass is same, only the weight will differ due to acceleration due to gravity. Okay, the reason behind that is acceleration due to gravity, that means the value of g, small g. Okay, so let's we were talking about moon. Okay, because moon is quite common to earth. Okay, and it is a natural satellite, so we can take example of moon. So the weight of an object on the earth is the force with which the earth attracts the object, and weight of an object on the moon is the force with which the moon attracts the object. That means weight of an object on earth is the force of attraction of earth only, not that of moon. And if it is in moon, then it is force of attraction of moon, not that of earth, because you are not in earth, you are in moon. Okay, say mass of the moon is less than the mass of the earth, so the moon exerts less force on an object than the earth. Okay, so the weight of an object on the moon is 1/6 of its weight on the earth. That means if your weight is 60 kg on the earth, your weight will be 1/6. That means how much? 10 kg. Okay, that means 1/6 of a weight. Okay, so we can say that the weight of an object in Earth and Moon has a difference. Okay, in Moon only 1/6 of the weight of the Earth is obtained. Okay, so let's see here Earth. Okay, mass kg 5.98, that is its value, into 10 to the power 24. That is because of its radius. Okay, because of its size. Because Moon is quite smaller than Earth. Okay. So then let's talk about thrust and pressure. What do you mean by thrust and pressure? Okay. So let's start with thrust. So thrust is the force acting on an object perpendicular to the surface. That means it is perpendicular to the surface. So when you stand on a loose sand, the force of your body is acted on an area equal to the area of your feet. Okay. And when you lie down, the same force acts on an area equal to the contact area of the whole body. So in both the cases, the force acting on the sand is the same. Okay, so if you stand, if you stand somewhere, the force acted on the surface is same, and if you lie down, the force acted will be same. As for example, let's talk about the weight also, mass. Okay, if you stand and weight your body, and if you lie down and weight your body, what will be the difference? Will it change? No, it will not change. It will be the same. So that is thrust. Okay, but pressure is different thing. Okay, so pressure is the force acting on the unit area of a surface. Okay, it is a force acting on a unit area of a surface. That means pressure is equals to thrust by area. So the effect of thrust on loose sand is larger while standing than while lying down. So if you stand, the pressure will be more. Okay, so pressure, as we talked, that it depends. Okay, and its SI unit of pressure is Pascal, PA. So I'll give you a simple example here. Okay, suppose you are standing on a what you can say, a sand only. Let's take a loose sand only. Okay, and if you are wearing a flat shoe, okay, that means the pressure that exerts, or your feet will go quite down. But if you, instead of wearing a flat shoe, if you wear a sandal, suppose, okay, then what will happen? The pressure will be more. Okay, the pressure will be more, and your leg will be more downwards. Okay, so that was the difference between thrust and pressure. We will be discussing with a pin. Okay, bolt pin, or what you can say, boat pin, whatsoever. Okay, so when a blunt pin is applied force, it does not go into the hood. Okay, whereas a sharp pin goes into the hood with the same amount of force. Okay, that means it depends upon the pressure, the thickness also. Okay, so if a blunt pin is inserted on the hood with the same force, and a sharp pin is inserted on the hood with the same amount of force, the sharp pin will go deeper than the blunt pin, or you can say the blunt pin will not penetrate. Okay, whereas the sharp pin will easily penetrate. That is because of a pressure. Okay, Thus, the effect of the force depends on the area of the object on which it acts. Okay, that means the area. Here, a blunt pin takes a more area, and on the right hand side, a sharp pin takes a less area. Okay, so that's why it penetrates easily. Okay, so let's talk about pressure in liquids, that means in fluids. Okay, so fluids exert pressure on the base and wall of the container. Fluids exert pressure in all directions. Means liquid and gas, they exert pressure in all directions. That means from left to right, from the bottom also. Okay, so pressure exerted on fluid is transmitted equally in all directions. So for that, we have to learn about buoyancy or upthrust. We talked about thrust, that means the pressure from the above. So upthrust means the pressure from the lower end, from lower to upper part. So when an object is immersed in a fluid, it experiences an upward force called buoyant force. This property is called buoyancy or upthrust. Okay, the force of gravity pulls the object downwards, and the buoyancy force pushes it upwards. Okay, the magnitude of the buoyancy force depends upon the density of the fluid. Okay, so what do you understand by buoyancy or upthrust? So just take an example of what you can say, a glass. Okay, take an example of a glass, or take example of that a plate, okay, or a ball, and try to push that ball inside the water, deep inside the water. What will happen? You will feel a pressure from the downward side, from the base of the bucket of a water filled with water. Okay, and that buoyant force is called upthrust. Okay, understood? So the force of gravity pulls downwards in a liquid, and upthrust pulls the object or forces the object at the upper level. So both the force help an object either to sink or to float. Okay, so let's see. So weight of a body partially immersed in liquid is 50 gram. Partially means not completely. Okay, weight of a body, let's say a stone is attached. Okay, and its weight is 50 gram. Okay, its weight is 50 gram, and it is partially immersed. That means not completely immersed. Okay, it's on the surface of the water only. Okay, now if we put that deep inside the water, fully immersed, that means its weight will be less. Why less? Because of the upthrust force or buoyancy. That is because of the buoyancy. That wise we can say that while swimming also, what will happen? We don't feel that something is pulling us from the beneath of the water body. Okay, we can float. We can float easily. That is due to buoyancy. Okay, so the principle of floating depends on buoyancy only. Now let's move towards float and sink. So why do objects float or sink? As for example, if a hood is thrown in water, it will float, whereas iron of the same weight, it sinks. Okay, why so? Does we have any difference there? Yes, we have. Okay, So if the density of an object is less than the density of the liquid, that means density. Okay, density means the compaction of the molecules. Okay, so if the density of an object, say for example a cock or a wood, okay, so its density is less than water, so it will float. Okay, and density of iron is more than water, so it will sink. Okay, so if the density in an object is less than the density of the liquid, it will float, okay, on the other liquid. And if the density of the object is more than the density of the liquid, it will sink in the liquid. That means it will go deep inside the water. We have a figure here also. That means we have a example of cock and iron nail. Okay, so density of cock is less than water, so it doesn't sink on water, it's float. Whereas we have nail, okay, so its density is more than water, so it sinks. So simple experiment or simple activity we can do. For that we have to take some water in a beaker and a piece of cork and an iron nail, okay, of same weight or same mass, okay, say 5 gram or 10 gram, okay, the mass must be same, so that you can easily say that the mass is same, but due to density either it floats or it sinks. So the cork floats because the density of cork is less, okay, and the upthrust of the water is more than the weight of the cork. The nail sinks because the density of the iron nail is more than the density of the water, and upthrust is less than the weight of the nail. So this was all about the object floating or sinking. Okay, same question here, but only we have a figure here. Okay, so iron nail sinks whereas cork floats in water. We have just experimented in our previous slide. So what do you mean by Archimedes principle? Okay, so Archimedes principle states that when a body is partially or fully immersed in fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Okay, as for example, what you can say, fill a beaker or a bucket, okay, and put stone there, okay, whatever the fluid is displaced, that means fluid is thrown out, okay, it's equal to the weight of that object. Okay, we can see figure here. Here a stone is attached and if put in a beaker or in a bucket, the same amount will be the same amount of liquid will be thrown out from the beaker. Okay, so it states that its principle has many uses. It is used in designing ships and submarines. So it is applicable, this Archimedes principle is applicable in designing ships and submarines. Okay, and the instrument or the meter, hydrometer, is used to determine the density of liquids, and lactometers is used to determine the purity of milk, etc. So that is the device or instrument used to measure the density as well as the purity. Okay, so we talked about Archimedes principle, and we talked about buoyancy also, upthrust, that is upthrust. When we talked about weight of an object in different bodies in Earth and on the moon. Okay, so Now we will talk about density. What is density? Okay, so the density of a substance is the mass of a unit volume of a substance. That means density is equal to mass by volume, and unit of density is kilogram per meter cube. Okay, we have a relative density also. The relative density of a substance is the ratio of the density of a substance to the density of what? That means in density we take mass of a unit volume, and in relative density we take ratio. Okay, so relative density is density of a substance by density of what? Okay, that means relative density is the ratio of similar quantities and it has no unit. Okay, whereas density has a unit, kilogram per meter cube. Okay, but relative density do not have units. Okay, it is only a ratio between two similar quantities and the unit is subtracted.